All right, today's lesson is lesson 4.3, congruent triangles. We just finished a previous lesson on 4.2, talking about congruent angles using triangle sum theorem and exterior angle theorem. Today we're going to use corresponding parts of congruent polygons, and we're going to prove that triangles are congruent using the definition of congruence. All right, so I have definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So in the example, you have corresponding angle A corresponds to angle H. So, and you can tell because they're both in red, that angle A is congruent to angle H, angle B is congruent to angle J, angle C is congruent to angle A. And then you have corresponding sides. Segment AB is congruent to segment HJ, segment BC is congruent to segment JK, and segment CA is congruent to segment KH. So because of that, I can say that triangle ABC is congruent to triangle HJK. So I've said that the corresponding angles are congruent to each other as well as the corresponding sides. That is the corresponding parts. All right, so I need to show that the polygons are congruent by identifying all of the congruent and corresponding parts, and then I'll write their congruent statement. So given I have that angle A is congruent to angle R, angle B is congruent to angle T, angle C is congruent to angle P, angle D is congruent to angle S, and angle E is congruent to angle Q. I also have that segment AB is congruent to segment RT. Segment BC is congruent to segment TP. Segment CD is congruent to segment PS. Segment BE is congruent to segment QS. And lastly, segment EA is congruent to segment QR. So because of that, I can say that polygon A, B, C, D, E is congruent to polygon R, T, P, S, Q. All right. I'm going to use corresponding parts of congruent triangles. So in the diagram, triangle ITP is congruent to triangle NGO. So this angle is congruent to this angle. I need to find the values of X and Y. So the first thing that I'm going to do is solve for Y. Because the two triangles are congruent, angle I corresponds to angle N. That's corresponding parts. Angle T, like I said, corresponds to angle G, and angle P corresponds to angle O. So I can probably figure out that the measured angle O must be 40. I'm going to write the equation, 40 equals 6y minus 14. Because remember that P corresponds to O, so 40 equals 6y minus 14. I'm going to add 14 to both sides. 54 equals 6y, so 9 equals y. Now I'm going to look at my corresponding sides. I'm going to look at my corresponding sides. So I know based on the name of the triangle that segment IT corresponds to segment NG. So these are congruent. So that means that 7.5 must equal X minus 2y. But I just discovered that y equals 9. So 7.5 equals x minus 18. I add 18 to both sides, and I find out that 25.5 equals x. All right, we also have what's called the third angle theorem. All this theorem says that if angle C is congruent to angle K, and angle B is congruent to angle J, then angle A and angle L are congruent to each other. So, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Alright, so here I have given a drawing of a tower's roof. It's composed of congruent triangles, all converging at a point at the top. I'm told that angle IJK, so this angle right here, is congruent to angle IKJ. So the first thing that I know, just based off of what I know from triangles, is that this is isosceles. It's not really important, but it's good to know. I know that the measure of angle IJK is 72 degrees. And because IJK is congruent to IKJ, this also has a measure of 72 degrees. So using the triangle sum theorem, I have 180 minus 144, which is the sum of these two angles. So the measure of angle JIK equals 36. That is the measure of angle JIK. Because all of these triangles are congruent, JIK is congruent to JIH. The measure of JIH is also 36. Proof right here. It says find the missing information in the following proof. Segment QN is congruent to segment OP, and they're marked as such. Segment QP is congruent to segment ON, and angle Q is congruent to angle O. Angle Q is congruent to angle O. Angle NPQ is congruent to angle PNO. We need to prove that the two triangles are congruent. So the first thing that I want to show you is that segment NP is congruent to itself by the reflexive property. Segment NP is congruent to itself by the reflexive property. So all we have to do is show that these angles right here are congruent to each other. So the third angle of each triangle has to be proven congruent. And we can prove that they're congruent to each other by the third angle. Third angle theorem. Okay? Look at that. Third angle theorem. And that's it. The last thing is just properties of congruence. We're going to talk about reflexive, symmetric, and transitive. The reflexive property of triangle congruence just says that triangle ABC is congruent to triangle ABC. The symmetric property says that if triangle ABC is congruent to triangle EFG, then you can reverse what the order on the equal signs. That means that triangle EFG is congruent to triangle ABC. And then the transitive property of congruence, if triangle ABC is congruent to triangle EFG and triangle EFG is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. And that is it.